Okay, I'm going to try and keep this a little bit shorter than the last couple of videos that I've recorded. And apologies for a little bit lateness and actually getting this clip on YouTube as well, but I broke the internet yesterday. Fortunately, it's all fixed now. So, coastal erosion, landforms of coastal erosion. This first bit should be largely revision from GCSE, as a lot of the content has been up to this point. Where you have a coastline with alternating bands of more and less resistant rock, as waves are hitting against the rock through the various forms of erosion, the less resistant rock is going to erode more quickly than the more resistant rock. The more resistant rock will be left sticking out as rocky crops, headlands, and the less resistant rock will erode backwards and form slightly more sheltered bays where erosion will actually be reduced over time. The reason for that is what's called wave refraction. The blue lines, as they're called, orthogonals, mark the position of successive crests of waves. At a headland, those orthogonals, paths of those crests, actually converge on each other. The result of that is much higher energy concentrated across a smaller area, whereas in the bays either side of the headland, the paths of the crests actually diverge. You end up with much lower energy waves by the time they reach the back of the bay. The result of that is obviously less erosion. So, once headlands are exposed to these higher energy waves, where the paths of the crests, the orthogonals, actually converge, they tend to follow a very characteristic sequence of erosion through different types of landforms. Thing to bear in mind is they're not just being attacked from the front, but as the paths of the crests are converging, they'll actually start to erode from the side as well, which is how we're looking at this headland from the side on. It will start off with natural lines of weakness, natural cracks in the rock, which various types of erosion will exploit. To begin with, they can actually form as the cracks widen, a very tall, narrow, steep-sided inlet, which is called a geo, G-E-O, as in the first three letters of geography. They, over time, can get widened out and start to undercut the cliff at the back, making a cave. Eventually, the cave can wear all the way through the headland, or you can have two caves from opposite sides that wear backwards towards each other, leading to an arch. What you can also get, which is not marked on this diagram, if water in the cave actually manages to find a line of weakness and erode upwards right the way through to the top of the headland, then you can get what's called a blowhole, where at high tide, particularly at stormy conditions, you can actually get rushes of air and sometimes bursts of spray actually firing up out the top of the headland from the cave down below. But if an arch does form, eventually it'll erode sideways and upwards. It'll get to the point where it can't support the weight of the rock above the arch anymore. That will eventually, over time, collapse, falling into the sea, leaving an isolated stack. Again, stacks can be attacked not just by the action of the sea, but by processes of subaerial weathering as well. The result of those can be a stump. And you can see from the dotted line marks on the screen there where the headland would once have been, and obviously how it looks now, and you can probably predict how it'll look in the future. So that's how headlands erode. The sequence goes crack, geo, cave, arch, stack, stump, with blowholes going off at a branch, I suppose, from cave as another possible pathway that the erosion could take. At the backs of bays, especially with much wider bays, where you have less sheltered conditions, so the energy of the waves is still relatively high, or alternatively right at the front of the headland, where waves are attacking it rather than from the side but from the front, you can get wave-cut platforms forming. The process is very simple. In fact, again, this should be GCSE level. The wave attack zone is fairly obviously the bit that is attacked by waves, which is, you'll notice, higher than high tide. Potentially this includes the very biggest storm waves, but the entire section of cliff that gets attacked by waves at any stage gradually wears back, and you get a wave cut notch, this bit where the cliff is actually being undercut. Over time, as that wave cut notch erodes backwards, the cliff becomes increasingly unable to support its own weight above the wave cut notch. The cliff will collapse, and the waves will carry the material out to sea. What you can end up with then, obviously, is the cliff eroding backwards, retreating is the technical term. The base, below the level that was being weathered and eroded, is left as a wave-cut platform. It's described on the screen there as a sloping rocky platform left behind as the cliff retreats. It's exposed at low tide. It tends to be, the slope of it tends to be less than about 4 or 5 degrees, very gently sloping, and it tends also to be less than about 500 meters end to end. The reason for that is very simply, as the wave cut platform gets longer, waves break further away from the cliffs, and also they have a longer wave cut platform to cross before they do break, causing them to lose more energy through friction before they actually do attack the cliffs. So there does appear to be a limit on how big wave cut platforms can ever get. Material that gets eroded and carried out to sea off the end of the wave cut platform can build up in what's called the zone of accumulation and form an offshore bar. But that's possibly more to do with landforms of deposition, which will be the topic of the clip I'm about to make after this one. The rate at which the coastline erodes has several different factors that will affect it, not least the rock type or the lithology. More and less resistant rocks will erode at different rates, obviously. Also, the structure of the rock, that is how it's laid down, whether it's in joints and bedding planes, whether the different types of rock run parallel to or perpendicular to the coastline, they'll all affect the rate of erosion. And also the dip of the rocks as well, where you've got layers of rock, different strata, that are either vertical or horizontal, they will tend to form steeper cliffs. Where you have rocks that dip gently towards the sea, they tend to make more gently sloping cliffs. If you've got rocks that dip steeply towards the sea, they'll tend to make quite steep cliffs, but not quite as vertical as the ones where you have horizontal or vertical strata. The length of the beach, as I was just explaining, causes waves to break further out and lose more energy before they hit the cliffs. That'll slow the rate of erosion down. Also, the material the beach is made from, coarser material like pebbles and shingle, will cause more energy to be lost through friction before the waves can actually break. Whereas sandy beaches, that's less the case. Less energy will be lost through friction, so there'll be more energy left in the waves by the time they do attack the cliffs. Human factors include building coastal defences, which will obviously reduce the rate of erosion if the defences are doing their job, although it can sometimes increase it further down the coastline. It doesn't stop the erosion, it just moves it somewhere else. And also development, clifftop developments can have implications in terms of altering drainage patterns and causing soil instability, which can actually lead to cliff failure. So humans can actually increase the rate of erosion in a place as well as decreasing it. To summarise, those are all the key terms that I've gone through, which will be useful for doing a bit further research for note taking. Those are probably the key terms. Landforms of coastal erosion, but also headlands and bays are the two main areas within which the other keywords will help you to add further detail. And I've left that picture of erosion of the cliffs at Mapleton up, even though I used it in my previous video, just because it shows the effects of cliff collapse, which seemed entirely appropriate. Right, I'm going to go and make